This is Module 1, Lesson 3. Here we're looking at operations with decimals. First, to write decimal numbers in words, we're going to follow these steps. We'll write the whole number part in words. Then we'll use the word "and" to represent the decimal point. And lastly, we'll write the decimal part as though it were a whole number in words, followed by the place value of the last digit. So, for example, if I wish to write 18.2 in words, well, the whole number part is 18. Then, to represent that decimal place, I'll write "and." Now, for the decimal digit, I'll write 2. And I'll use its place value to represent what place it's in. So the 2 is in the 10th spot, so I write tenths. So, rather than 18.2, we can say that this is 18 and 2/10. For our next number, looking at 43.253, I'll write 43 for the whole number. I'll use "and" to represent the decimal place. Now, for the decimal, we see that as a whole number, it would be 253. Now I need to write the place value of that 3 at the end. So that 3 is in the third place over, the 2 is the tenths, the 5 is the hundredths, the 3 is the thousandths, so I'll end my word with thousandths. So altogether, this is 43 and 253 thousandths. Now let's write each decimal number in standard form. So first, I have 39 and 16 hundredths. So that would be 39 is the whole number, where I see "and" I put in my decimal place, and then I have 16 hundredths. So I need to make sure the 6 of that 16 is in the hundredth spot. So we would have the tenths and the hundredths, so I can fill in exactly 1/6 for 16 hundredths. Now next, I have 39 thousandths. Well, there is no whole number here, so I'm going to start off with 0 as my whole number, a decimal place. Now I need 39 to be in the thousandths location. So we have the tenths, hundredths, thousandths. Therefore, 39 fills in those last two spots, and I have to put in a 0 as a placeholder to push that 39 all the way to the thousandths place. Now let's look at comparing decimals. When comparing decimals, we should line up our decimal points in order to identify which one has the highest place value. So in part A, first I'm just going to write these numbers out vertically so I can see where the decimal places are. So I have the point 063, the point 006, and the point 060. Now the largest one of these will have the largest number in the first place value working from left to right. So I see either my top one with the 6 or the bottom one with the 6 would be the largest. Then I go to the next digit over and I see the 3 is bigger than the 0. Therefore, this 0.063 or 63 thousandths would have to be my largest. Then I would have this 60 thousandths next, and lastly, my smallest would be that 6 thousandths. So since this question asked us to write them from smallest to largest, I would say I have 6 thousandths first, followed by 60 thousandths, followed by 63 thousandths. Okay, let's look at part B now. So once again, I'm going to line these up vertically in order to identify where their place value is. So I have the 26.060, the 25.83, the 25.803, and the 25.083. So let's identify these from largest to smallest first, then we'll rewrite them in reverse order. So the largest, well, would have the overall largest number, the largest whole number, so that would have to be this 26 because all the rest are 25. So that's the largest. Now for the next one, since they all are 25 as the whole number part, I need to go to look at the decimal. So next I see an 8 in the tenths place for these two, so those are certainly bigger than the one with the 0 in the tenths place. I move over my next digit for those two that have the 8 in the tenths place, and I see a 3 versus 0. So the one with the 3 would be the next largest. The one with the 0, well, the 8, 0, would be the next largest. And lastly, with the 0, 8, 3 would be the smallest. So writing these from smallest to largest, I have the 25 and 83 thousandths, the 25 and 803 thousandths, the 25 and 83 hundredths, and lastly the 26 and 60 thousandths. Okay, now we're going on to rounding decimals. So we're going to round each decimal to the given place value. So first, for part A, I'm looking at rounding the 487 thousandths to the nearest tenth. So if I want to round to the nearest tenth, which we know is that first decimal place where that 4 is, I need to look at the decimal to the right of it, which is that 8. Since the 8 is 5 or more, I round up. So I'm going to round this to 0.5. I bump that 4 up by 1. In other words, it's 5/10. Now for part B, we want to round 234 and 634 thousandths to the nearest 10. Well, the nearest 10 is this 3 right here, so we need to look at the 4 next to it to decide whether to round up or keep the same. Since the 4 is less than 5, we'll keep the same, meaning we'll write this as 230. For part C now, we want to round $30 and 4,062 ten-thousandths to the nearest cent. Well, the nearest cent means 2 decimal places, so that's this 0 here, meaning we need to look at the 6 next to it to decide how to round. So since the 6 is more than 5, I'll round up to $30 and 41 cents. Finally, for part D, we want to round $4,123 and 46,723 hundred-thousandths to the nearest dollar. So we're looking at the dollar place, that 3, so we need to look to the right of it at the 4. Since the 4 is less than 5, we'll keep the same, so we'll write this as $4,123. Now we're moving on to adding or subtracting decimals. So to add or subtract, we need to write the decimals so that the decimal points line up vertically. Then we'll add or subtract as if we were working with whole numbers. And lastly, place the decimal point in the answer so that it lines up with the decimal point in the problem. So first, if I wish to add 24 and 63 hundredths plus 25 and 9 hundredths, I should line this up vertically. So I have the 24 and 63 hundredths plus the 25 and 9 hundredths. So now I'm going to just add as if these were whole numbers. So I'm doing 9 plus 3 to get myself 12. So I put down the 2 and I carry the 1. 6 plus 0 is 6, plus that carried 1 is 7. 5 plus 4 is 9, and 2 plus 2 is 4. Now at the end, I need to carry down these decimal points right to the answer. So my answer becomes 49 and 72 hundredths. Now let's look at subtracting. So now I have 120, and I wish to subtract off 17 and 53 hundredths. Now for that 120, the decimal point, even though it's not written, is at the very end of the number. So that's where I want to line up the decimal of the 17 and 53 hundredths. So now if I'm trying to subtract, it would probably be useful to fill in these place values on that 120 so that both numbers have the same amount of place values. So I'm trying to do 0 minus 3 first. Well, to do that, I need to borrow. I can't borrow from the next 0 over because it's 0. I can't borrow from the next 0 over, so I have to go and borrow from the 2. So from the 2, I'll borrow 1, which means this next 0 becomes a 10. But again, I need to borrow from that 10 so that I can carry it to my next place over. So I'll borrow from the 10 to make it a 9. Same idea, I'll be making this now a 10, but I need to borrow from that and make it a 9. And lastly, I'll make the last part the 10. So I'm doing 10 minus 3, which is 7. Now I have 9 minus 5, which is 4. 9 minus 7 is 2. 1 minus 1 is 0. And lastly, I have 1 minus, well, there's nothing in that outermost place on the 17, so that would be 1. Lastly, we're bringing our decimal point from the problem right down into the answer. So my answer is 102 and 47 hundredths. Now, for multiplying decimals, we'll multiply the decimals as though they were whole numbers. Then, at the end of the problem, we'll place the decimal point in the answer so that the number of decimals in the answer is equal to the total number of decimal places in the original problem. So for example number 9, if I want to do 1 4/10 times 3 2/10, first I'll line the problem up vertically like I'm going to multiply with whole numbers. I'll multiply through by that 2 first, so 2 times 4 is 8, then 2 times 1 is 2. I'll put my placeholder of 0 at the end. Now I'm multiplying through by the 3. 3 times 4 is 12. I put down the 2 and carry the 1. 3 times 1 is 3, plus that carried 1 is 4. Now I need to add, so 8 plus 0 is 8. 2 plus 2 is 4, and then the 4 at the end. Now I need to go back and place my decimal point. Normally, if this were a whole number, 448, the decimal point would be at the end. But since my original problem had 2 decimal places in it, I need to move that decimal point from the end in 2 places. Therefore, when I do 1 4/10 times 3 2/10, I come up with the final answer of 4 and 48 hundredths. Now, in order to do a quick check of this answer, I should go ahead and estimate my original problem. So I'm going to round each original number to the nearest whole number so that I can do a quick multiplication check. So this 1 4/10, the 4 at the end tells me to keep the whole number as a 1. So 1 4/10 is closest to 1 as a whole number. For the 3 2/10, that 2 tells me to keep the 3 as the whole number. So I'm doing 1 times 3, and I end up with 3. Well, I would say that 4 and 48 hundredths is very close to 3, so that's a good approximation for our check. Now for example 10. We want to find the product of 7 and 2 and 361 thousandths. Well, the order of multiplication doesn't matter, so I'm going to choose to write the 2 and 361 thousandths as my top number that I'm multiplying by 7. I did this because I like the number with the fewest digits as the second number so that I don't have to go through as many rounds of multiplication. So now I'm multiplying through everybody by that 7. So 7 times 1 is 7. 7 times 6 is 42. I place the 2 and carry the 4. 7 times 3 is 21, plus the 4 is 25. Place the 5 and carry the 2. 7 times 2 is 14, plus 2 is 16. Now that I've finished my multiplication, I need to count the number of decimal places in the original problem. I see there were 1, 2, 3 decimal places. The 7 doesn't have any decimals associated with it. So in my final answer, I normally would have my decimal place at the end, but I need to move it in 1, 2, 3 places. giving me a final answer of 16 and 527 thousandths. Now, as a good approximation or check to this answer, I'm going to round each number in the original problem to the nearest whole digit, and then I will approximate by multiplying. So the 7 in the original problem is closest to the whole number 7. I don't need to round that. But for the 2 and 361 thousandths, I'm going to round it to the nearest whole number, so I'm looking at the 3 in the tenths location, which tells me to keep the whole number where it is at 2. So I'm going to do 7 times 2, which we know comes out to 14. Well, I would say that 16 and 527 thousandths is close to that 14, so that's a good check that we got our answer correct. Now let's look at multiplying decimals by powers of 10. So if I want to do 43 and 543 thousandths times 1,000, I could set this up vertically just like I've been doing. But notice that the first 3 rounds of multiplication, I'll be multiplying through by zeros, which we know that 0 times any number is 0. So essentially, I'll be giving myself 3 zeros as placeholders before I now go through and multiply by that 1. Well, multiply through by 1, I have 1 times 3 is 3, 1 times 4 is 4, 1 times 5 is 5, 1 times 3 is 3, and 1 times 4 is 4. I now count my decimal places, 1, 2, 3. So from the end, I move in 1, 2, 3 places, and I see that my answer comes out to 43,543. Now this is perfectly fine, but notice that I have the same exact digits as the original problem, the 43 and 543 thousandths. These digits have just changed place value by multiplying through by that 1,000. A shortcut to this problem would be to recognize that when we multiply by a power of 10, that is a whole number power of 10, such as 1,000, our number is going to get bigger by the number of decimal places corresponding to the number of zeros in the number we're multiplying by. So what I'm saying, there are 3 zeros in 1,000, therefore our original number of 43 and 543 thousandths is going to increase in size by 3 decimal places. So since the original decimal started here between the 3 and the 5, I'm going to increase it 1, 2, 3 places and put that decimal at the end of the 3, just like we have in our answer, leaving us with 43,543. Now, if multiplying by a whole number power of 10 is going to increase the size of our answer, multiplying by a decimal power of 10 or fractional power of 10 will decrease our answer. So we see if I'm doing 141 and 2 tenths times 1/100th, well, there are 2 decimal places in that power of 10 that I'm multiplying by. So that's telling me I'm going to decrease my final answer by 2 decimal places. Well, originally the decimal is here between the 1 and the 2. So I'm going to decrease it by 2 places, meaning I'm going to move it 1, 2 places in between the 1 and the 4. So my answer then will be 1 and 412 thousandths by decreasing it by those 2 decimals. If we were to set our problem up vertically, we would see the same result. The last operation we're going to look at with decimals is division. When we divide decimals, we're going to set up long division and then move the decimal place in the divisor until the divisor is a whole number. Well, if we move the decimal place in the divisor, we must also move the decimal place in the dividend the same number of places. We'll divide as if they were whole numbers, and then place the decimal point in the quotient, or our answer, directly above the decimal place in the dividend. So for example, if I'm doing 30 and 4 tenths divided by 8, well, I would set up long division, 30 and 4 tenths divided by the 8. Now notice that the number on the outside, the 8, is already a whole number. so I don't need to move any decimal places. So in my answer, my decimal place is going to go directly above the decimal in that divisor. Now I'm asking, does 8 go into 3? It doesn't, so I need to move over. Does 8 go into 30? It does. It goes in 3 times. So 8 times 3 is 24. I subtract. Looks like I'm going to need to borrow from the 3, make that a 2, and make the 0 a 10. So 10 minus 4 is 6, and then the 2 minus 2 is 0. I bring down the 4, and now I ask myself again, 8 goes into 64 how many times? In this case it's 8. So 8 times 8 is 64, and we subtract to see 0 remainder. So we're saying that 30 and 4/10 divided by 8 is 3 and 8/10. Now let's do a quick check by estimating our answer. So to estimate, I could round each number to the nearest whole number. For example, I could say 30 and 4/10 is closest to 30 as a whole number, and 8, of course, is closest to 8 as a whole number. But I can't really do 30 divided by 8 in my head. However, I do know that 32 divided by 8 is equal to exactly 4, and that is pretty close to my answer of 3 and 8/10. So that would be a good check. In this case, even though I didn't estimate by rounding appropriately according to normal rounding rules, I was still able to estimate by picking numbers that were easy to divide, that were still close to the original numbers. Okay, so for another example, now I have 5 and 76 hundredths divided by 3 and 2/10. So I'm going to put the 5 and 76 hundredths inside my divider. Say I'm dividing it by 3 and 2/10. Well, in this example, my divisor, 3 and 2/10, has 1 decimal place. So I need to move that decimal place over by 1 to make it the whole number 32. Well, if I move the decimal place there, I must also move the decimal place inside my dividend. So rather than 5 and 76 hundredths, I'm going to move it in to be 57 and 6/10. So now in my answer, the decimal place needs to go directly above where the decimal place is in the dividend. So now I go ahead and divide as normal. So I'm asking, does 32 go into 57? Yes, it does. It goes in 1 time evenly. So 1 times 32 is 32. I subtract. 7 minus 2 is 5. 5 minus 3 is 2. And I bring down the next number of 6. Now I need to ask myself, does 32 go into 256? Well, it looks like it goes in 8 times. So 8 times 2 is 16, carry the 1. 8 times 3 is 24, plus that carried 1 is 25. I subtract to see a 0 remainder. Therefore, our original problem of 5 and 76 hundredths divided by 3 and 2/10 comes out to 1 and 8/10. As a quick check, I can first start by rounding each number to the nearest whole value. So 5 and 76 hundredths would round to 6. I want to divide that by 3 and 2/10, which rounds to 3. 6 divided by 3 does come out nicely to 2, and I can see 2 is pretty close to that 1.8, which is a good check. Lastly, we need to look at dividing by powers of 10. Now remember, when we multiplied by powers of 10, my answer got bigger if it was a whole number power of 10. So if I divide by a whole number power of 10, my answer should get smaller. So if I'm doing 43 and 543 thousandths divided by 1,000, well, the 3 zeros of that 1,000 should make my answer get smaller by 3 decimal places. So I'm going to move my decimal in the original problem over 1, 2, 3 places, which means I need to fill in a 0 then for 3, 0.543 and have my decimal place right before that 0. Now, normally we do fill in the whole number 0 before any decimal places, just so it's very obvious that that decimal place is there, and it doesn't just look like a pen scratch on the paper. For our last problem, we're going to do 1 and 243 thousandths divided by 10. So once again, since I'm dividing my decimal by a whole number power of 10, my final answer will get smaller by the number of decimal places according to the number of zeros in the power of 10. This 1 0 here will make my final answer smaller by 1 decimal place, so moving it over 1 decimal place, we'll see my answer would be 0.1243, or in other words, 1,243 ten thousandths. Again, I'll put the 0 in before that decimal place.